Welcome to Sravz Technical Series. In today's session, we'll discuss Golang context package. So we're going through the Golang crash course, and we had a bunch of videos here. So in today's session, we'll discuss the Go context package and the usage of it. So I'll switch to the code base. So the code is uploaded to the GitHub, and we will discuss the main.go package for main.go file today. So there's a lot of discussion here. We'll start from line number 98 onwards. All the previous code was discussed in the previous videos. So now the context package. Golang's context package defines context type, which carries deadlines, cancellation signals, request scope across API boundaries. So we'll try to understand what that means. Also, we can pass context across functions which run in different Go routines. Now, if you recall from the Boost-based discussions, Boost-based WebSocket server, API server, it's all C++ based. There we had a shared session class out of which we created an object and we newed it, created an instance of that. And then since it's in a heap memory, we kept that shared state there and multiple threads were accessing that shared state. And then within the shared state, we had a mutex to guard the sensitive information when there were multiple writes. But for parallel reads, we let it be. We didn't put any mutex. So that's how we did it in C++. But in Golang, there's a facility with which we can do the same using context. A context is a package based on which you can you can add your information to context is an interface with which we can use it across the API boundaries. So let's start with the to-do context. So for example, you you write a function which in future will take a context, but today you don't know what type of context it's going to be, because context can be various types like value context, cancelable, cancellation context, context with the deadline. We'll discuss those in a bit. So if you don't know what type of context to use, the best practice is to define a to-do context. So here at line 107, we defined a to-do context and then we passed it to this function, empty context function. So the empty context function, which we are going to update in the future, but today since we don't know, we provide a context in the beginning. Again, it's the Golang best practice is to have the first parameter as a context and other parameters next to it. So if you look at Gorilla Mux, most of the functions have context in the beginning. So for example, those functions which are going to do a DB calls, the functions which are going to do REST API calls, etc., which you need to cancel if the user has stopped, closed the browser. So in those kind of scenarios, you need a context parameter. So in this case, since we don't know what type of context it's going to be, so we created a to-do context and we passed it to empty context function. And the code base is running right now, so I'll show the value here. So it said to-do context with value nil. We'll try to discuss the value later, but for now it shows it's a to-do context. So it's just a simple function which took a to-do context and we printed it here. Next, we do a background context. So to-do context is more for design, developer design usage. You have a function, but you don't know which context to use. You do a to-do context. The background context is the main background context, which is a non-nil empty context, which is used in the main functions, initialization and tests. So for example, main.go is my main function. I want to start a context. I start with the background context. So this one would become my parent context or the root context. So in this case, I created a background context and then I passed it to this function, which again does the same. It just prints that it's a background context. So nothing more regarding that. Now, say for example, I have a function which will take this context, a background context, but to that function, I want to pass in a value. Say for example, in the main function, I have the user ID. Based on the user ID, I got some more information. Now I created an interface or a structure for that user information, and I want to pass this information to some other function which is going to run in a Go routine. Then I can pass the whole structure as a parameter, or I can put it in the context. In this scenario, user information is preferred in a context. So for example, that is the case. So I didn't use user as a key, but I just a generic key I've used here. So I created a key called key1, and then I put a map in it, and then I used a context with value, and I passed the background context one. So everything starts with a background context. It's a parent-child relationship. Whenever somewhere you create a context, it has to take a parent context. So here I took a parent context, my background context, and to that I added a key called key1 and some value, which is a map. So it has to be any interface is fine, but it has to be your own type. So for example, here I created a type of string, a custom type of string. We have to create custom types of our own custom types. We cannot use built-in types. Built-in types can be used, but that would give, that is not recommended. So here I created a custom type key and I passed some value to it. So now using my background parent context, I created a context with value where I put a key and a value. So that's how a parent-child relationship is established. Now in with value, context with value function, context, so I call empty context function with context with value context. So I just print the key value there. So I printed the context type and then the value in that key. So here we did context with value and we printed the value. Next we go to the child context. As I mentioned, the context of parent-child relationship. So to demonstrate that, the next thing what I did was I call the parent context function with context with value, which we created here, in which we created a key1, and we put some value in there. And then in that function, parent context function, in the context with value, I updated the key1 to some other value, child value. So that way I get a child context of the parent context. And in the child context, since I updated the key1 to some different value, I passed it to this function, child context function. And in the child context function, I displayed the same key1. So before calling the child type, context with value had that map. Right? Before calling child type, I had some map in it. Then I created a child context. I updated the value to child value. In this function, I still use the parent context and I printed the key1. It shows the map. So what we demoed in this is, once you set a key to in a context, it is immutable. It cannot be changed. So once we created a child context of the parent context And in the child context, when we updated the value in the parent context still remains same. Value in the child context will be changed. So that's what happened here. The value in the child context is different, but in the parent context, it still remained the same. So that shows the relationship between parent and child context. And the key in the parent context is not updated when the value in the child context is changed for the same key. Next, we go through so we discuss the parent context. Next, we discuss the cancelable context. So we create a context using the same background. We created a context with the parent background context, which is cancelable. Now, cancelable gives us a cancelable function. And when we pass this context with cancel to a function, cancelable context, and this is the cancelable context function. So the cancelable context provides a function called cancel. So with cancel, it's similar to signals. Once you, for example, in multi-process system, once you signal the other process to send a signal to the other process, the other signal will catch that signal. Say, for example, sig interrupt or sig term. In FOSIX C++ programming, you can use signals to communicate between processes. Similarly, in Go, you can do that using this cancel function and channels. When you use with cancel, you'll get a function called cancel function. When we call the cancel function on the context, we get the function called done, which returns a channel. And this channel is closed when the cancel is called. So this way you can do interprocess communication. So for example, in this scenario, say for example, the main Go routine or main thread is called cancel on the context. And in here, there's a Go routine which is running separately. A Go routine runs on a separate thread or a separate green thread. So this Go routine done calls a done function which returns a channel, and this channel is closed when the cancel is called. So this way, this Go routine will know when to exit based on the cancel call by the main process. So this way you can do an interprocess communication. So if you look at the description here, done with cancel arranges for done to be closed when cancel is called. So since this channel is closed, we print this cancelable context done, and then we return from this for loop, which is a busy loop. So this Go routine will exit. So that's what we did here. After calling child type, starting busy loop, we started a busy loop. Then we printed some data in this case. Then done is called, cancelable context done, and it came out of this function. So that's the usage of cancelable context. So for example, you have two processes and the other one is a long running. From the main, you want to let the other process know that it has to close itself. Then you can do a cancelable context, and then you cancel the context. The other Go routine will know that the main has asked it to cancel out, and it will stop its processing. So that is cancelable context. Next, we have a context with deadline. Now suppose you want to run a Go routine, but you want to give it a specific time, like run it for 3 seconds, 4 seconds, and then exit out. Then you use a context with deadline. In context with deadline, we again use a background context, and then we give it a time. In this case, we gave it a 2 seconds timeout. So we'll trigger something, a go routine. We give it 2 seconds and ask it to exit out after that 2 seconds. So that is the usage of context with deadline. So I'll go to that context, that function. We started a busy loop. Then on the context with deadline arrange for done to be closed when deadline expires. Deadline is a timer. Once the timer expires, this function will stop processing. So for example, say you want to open a wget session with or curl session with some remote HTTP server, and you want to give it like 3 seconds to connect, if not exit out, then this is the scenario where you can use context with deadline. Now the next type is context with timeout. So cancel with timeout and cancel with deadline. There are two types of context. Now the difference between these two is the way they are called. Context with deadline, you have to provide a deadline here. So if you look at the way a deadline timer is set, it starts from now to some time, 2 seconds in this scenario. So before this function is called, context with deadline, you have already started the timer. So even though you're expected to wait for 2 seconds and then you started the timer, then call the function, this function wouldn't have run for 2 seconds. It would run for much less than a little less than 2 seconds, because you have started the timer and then call the function, because deadline starts from now into the future. So that's the one disadvantage with deadline. So if you want to give the correct time to the function, then you have to use context with timeout. Timeout will take the full 2 seconds to run. So we call the context with timeline, and the rest of the process is the same. We call the context with the timeout function. Then we wait on the done channel. The done channel timeout arranges for done to be closed when the timeout elapses. Then after that correct timeout, this function will exit out. So that's what we do with context with timeout. As a best practice, it's recommended to cancel even if you have deadlines and timeout. And that's a scenario where, for example, say you have timeout to a DB connection for 10 seconds, but for some reason the user has closed the browser, so you want to cancel it. So you want to cancel it before the deadline or the timeout expires. So it's a best practice to call the cancel again. Sometimes people put defer cancel, so whichever is preferred, defer cancel like I did here, or you just put cancel here. It doesn't matter how many times you call cancel on a context. The channel will not throw an error. So cancel can be called as many times you want to. Now we'll see a practical usage of context with timeout. So a practical usage of context with timeout is in Gorilla Mux. In the Gorilla Mux program, in the end, we created a channel of type in OS interrupt signal, and then we wait on that channel. Once we press Control C, we cross this line 151. Then we start a context using the background of wait time, context with timeout, and then we shut down the Gorilla Mux server with that timeout, so that pending request can be processed for that timeout. So if you go to the shutdown function, Gorilla Mux does a loop here, busy loop, and then it waits on the channel timeout arranges for done to be closed when the timeout elapses. So once the timeout elapses, this channel, this select is exited out, for loop is exited out. So all the cleanup activity is done till then. And then we do a defer cancel to cancel this context, and then we exit out of the program. So this is another practical scenario where timeout, context with timeout is used. With that, I'll close today's session. If you have any questions, please reach me out in the YouTube channel or in the documentation discussion page here. Thank you for watching.